By now you may have noticed the formulas here on the screen on your formula sheet. We're going to have a look at them one at a time and see what they mean, and then give an example for each one. These first two formulas are useful when we want to multiply a distribution by a certain amount or add something to the distribution. These second two formulas are useful when we're wanting to add two distributions together. Let's have a look at an example for the first one. In this example here, we have a salesman who earns commission of $10 for every TV he sells, plus a fixed rate of $30 each day. He sells on average 4.3 TVs per day with a standard deviation of 0.3 TVs. Now we want to calculate the mean and the standard deviation of how much he will earn each day. Now, we remember that the expected value of x is the same as the mean, which we use the symbol of mu for, and the variance of x is the same as the standard deviation squared. So, let's have a look at what we put into this formula. We've got a formula of the expected value of ax plus b is equal to a times the expected value of x plus b. So this is kind of just common sense. If we earn $10 for each TV we sell, and we sell on average 4.3 TVs, which is our mean, and we get $30 extra per day, that means we're going to get 43 plus 30, which is $73 on average per day. Now, the standard deviation is where it gets a little bit trickier. So, we have the variance of ax plus b is equal to a squared times the variance of x. Now, you'll notice that we haven't added that extra 30 on. And that's because if we've got a distribution that looks like this, and we add 30 onto it, it's going to look like this. It's not going to get any more spread out. The mean's going to change, but the standard deviation doesn't if we just add the same amount to each value, which is why we don't add on that b at the end. So, a squared is going to be the amount of commission for each TV, which is 10 squared times our variance. Now we're told that our standard deviation is 0.3, so our variance is going to be 0.3 squared. Now, if we type this into our calculator, we'll find out that that is equal to 9. Now, what we want to find out is the standard deviation. So the standard deviation is always just the square root of the variance. So the square root of 9 is equal to $3. Right, let's have a look at an example for the second group of formulas. These are for when we're adding two distributions together. In prescription glasses, the weight of the lens is 9 grams with a standard deviation of 2 grams. The frames have an average weight of 6 grams with a standard deviation of 1 gram. The material for the glasses costs $3.20 per gram, and the material for the frame costs $2.50 per gram. What is the mean and the standard deviation for the cost of the material in the glasses? So, let's have a look at the first formula. We're told the expected value of ax plus by is equal to a times the expected value of x plus b times the expected value of y, which is kind of what we'd expect to see happen. This means that if the weight of the lens on average is 9, that's our expected value for the lens, and we're told that the material in the lens costs $3.20. And if the weight of the frames on average of 6, that's our expected value of y, and we're told they cost $2.50. So, if we type that all into our calculator, we find out that the average cost is $43.80. Let's look at the second one. Now, it's very tempting just to add the standard deviations together. Now, you can't do that. There's all sorts of reasons around why you can't do that, but for now, just accept that you can't do it. Now, the formula for this then is the variance of ax plus by is equal to a squared, the variance of x, plus b squared, the variance of y. So, if we come along and substitute the values that we have into this, we know that a is 320, so we're going to need to square that, and the variance is just the standard deviation squared, which in this case is 2 squared, plus the value of b is $2.50, So 250 squared, standard deviation of y is just 1 gram, so it's going to be 1 squared. If we type that all into our calculator, we'll find out that that's equal to 47.21. Now, we need to remember that that's not the standard deviation. To get the standard deviation, we need to square root 47.21, which is equal to 6.87 rounded to 3 significant figures. It's worth remembering that this is one of the trickiest concepts in the standard, so if you haven't got it, the best thing you can do is practice, practice, practice.